Hi everyone, welcome back to Classic Arcade Repairs. Today, I just got a BurgerTime out and set it on the bench. And the first thing I noticed trying to remove it from this cage, look at how bowed this is. Look at this. That doesn't look right, does it? I don't like that at all. Anyway, I'm going to go ahead and this just doesn't even set right. I don't know. This is weird. I'm going to go ahead and remove this board set from this thing. If I have to remove this brace here, I will. But yeah, that's very weird. So let's get it out of this thing first and foremost. BurgerTime on the bench removed from that cage. I have it all hooked up. Tested the voltage. We're at about 5.9 or 4.9. So that's good. And I turned it on and I get this. It's not really doing anything, is it? It's just got like a high score table or something like that. And that's really it. So it's not doing anything. Yeah, not doing anything. Interesting. Alright, well, what's the first thing I want to do? It's concerning because a common failure on these is that CPU box. And it looks like we have no CPU action going on. So it's probably, I mean, it's a possibility that that is no good. I could definitely test the ROMs. So I think I'll do that is I'll test out all of the EEPROMs and just dump them and verify that they're good. I can reseat them for sure, because these sockets are not the best. And there's a 6116 RAM on this CPU board that I can test. I don't think that's an issue though. I don't. It might be. You never know. But it's always a good place to start to dump and test EEPROMs. That's kind of what I always like to do anyway, to start off. But we're not doing anything CPU wise on this board set. So it's not running at all. So let's do that. Let's verify that our software is good. And our main program RAM, that 6116, I do want to make sure that that's okay. And if all of that checks out, then I'm going to start suspecting this big block CPU thing. So, alright, I'm going to get to it. Start dumping these EEPROMs and making sure that they're okay. I think that these four right here, or maybe these five, are the actual program. And then four of these are video. I might have to go back over one of my videos because I have that. I used to know which was which. Now I don't. Maybe this is the program, these four guys right here. I'm not sure though. But we'll figure all that out. Let me go ahead, get this all disconnected, separate the boards, and verify software and RAM. Alright, well, I did go ahead and I reseated these cables, and that's really about it. And it's running now. but we still have the graphics issue. But you can see it's actually running, the program's working, so that's good. So all we have to do is figure out our video issue. Yeah. And do we have sound? I don't know. Let me go ahead and mess around a little bit with figuring out sound. I'm going to just try turning it up and making sure I have my sound plugged in correctly and all that good stuff. So let me do all that. The sound is fine, and the game plays fine, just doesn't look good. So let's look into that. Okay, yeah, we're still here. I still haven't done anything really. Plan of attack. What I'm going to do is I am going to dump all of the ROMs. I'm going to go ahead and do that, and then I'm going to take them in and verify them against ROM ident, make sure they're good for one, and number two, find out exactly which is the graphics, which is the CPU. I'm not worried about CPU ROMs. I want to know which banks are the graphics ROMs. I know these are, but are they sprite? I don't know what kind of graphics. This is the board I'm not sure about. Which bank is graphics, which bank is program. So I'll go in on the computer and verify them against ROM ident. That'll tell me if it's graphics or main CPU. And then I can go to the schematic and start and figure out which is sprite and which is actually background tiling and stuff. 'Cause that's the problem, is the background tiling. Our sprites look fine. Sprite placement, sprite data. There's no problem there. It's all the backgrounds. So I'll figure that all out once I get to the schematic. But first, I do want to verify that all of these ROMs are good. I know the program ROMs are good, so I'm not so worried about that, but I'm not exactly which ones are program. I could figure it out if I looked at the schematic. But while I got my programmer out, I'll just dump them all. It's no big deal. So I'm going to go ahead and do that. Make sure all the graphics ROMs are good, because this could very well be ROM. It could be a bad ROM for sure. But yeah, we'll eliminate that and then move forward from there. Okay, we're looking at the schematic. I'm going to just kind of bring it in a little bit. Okay. I tested all of the EPROMs and they were all good. No problem. Now it did say in ROM ident the region for this guy right here at 6B, this EPROM right here, is background mapping. And you can see here it is the output of this EPROM, and it's always active, it's always on, so it's always spitting out data. And its contents are latched in this 374, which is 374. This must be pin 17. Pin 17 is data, is a data bit. 7 data, where's 7Q? Right here. Okay. So, okay, that's either here nor there, it don't matter. Anyway, this is spitting out, it's latched, and at a timing interval it's spitting this data out onto this bus, the VR bus, let's call it. Video row address bus. So, and that's these 3 EPROMs, 2716s at 1B, 3B, 4B. Okay, those guys are spitting out their data, and I believe that's per row, per vertical row of what is being blitted out to the screen per vertical row. So I think that's where our failure is occurring. We had the map row, the map ROM address. Now these ROMs are all good, so it's something logically connected to these ROMs or in this circuit. It's got to be, right? We have a map address ROM, map ROM address bus, which comes from this LS283. The sum of this 283 right here is map 0 through 3, and then map 4 and 5 are over here. Let me move this a little bit. Right. Yeah. And, okay, right. Let's go right here. Let's try that. Here's map 4, map 5, M4, M5, M6, M7, and M0 through 3 are right here. Okay. 6 and 7, 4 and 5. 6 and 7 are static. 6 is ground. 7 is preset. So yeah, this is a 74. So that's preset. That's going to be pulled high. So 7 and 6 are static, low and high. Okay. 4 and 5 are signals that are derived from this 74 here. And that comes down, that's that bus. And this is interesting. You see, this says 10H, 20H, 40H, 80H. Weird sync signals. Very strange. That's probably why this board set has such a hard time syncing to monitors. This is the vertical counter bus, which is also addressing this ROM. It's addressing A0 through A3 with 10V, 20V, 40V, and 80V. You know, those are just strange vertical counts, strange counts, sync counts, period. And I know that I have had problems with this board syncing to monitors, and that has got to be why. Because those are just strange counts. Normally you see, 2, 4, 8, 16, 32, 64, 128. These are just strange sync. Anyway, so those are our addresses for this mapping ROM. Okay, so we can definitely probe around on these and make sure that our 283 looks like it's doing its job and spitting out a number that makes sense here. We can actually analyze that too. Horizontal lines, I'm sure, are fine. I think the horizontal and vertical counts are fine. I don't think it has anything to do with those. I think it's got more to do with this M0 through M7. And the reason why I don't think it's these vertical or horizontal counts is because we have sync. It's the board set is synced up to the monitor. That tells me that the sync signs are fine. The failure is something other than that. So we can definitely check this 283 for this sum. We can check this 74 for these two bits, right? And then we know this ROM is good because I dumped it. I know that these vertical counts are fine. So let's assume these check out fine from the 74 and the 283. These guys right here. Let's assume that we check that and it's fine. Next thing we can look at is we can look at this 374. We can look at the clock of this 374. We're going to kill two birds with one stone, or as Ricky from Trailer Park Boy says, we can get two birds stoned at once. If we look at this 283 and it's fine, then we'll know that this data bit's fine on this guy. So we can look at the clock, then we can look at this 374. You know, it's functional. How is it functioning in spitting out this latched data? And if that checks out fine, then we can move to, here's this vertical row bus. And we know these ROMs are fine. We know our vertical counts are fine in addressing on this. So we're not worried about that. Then we have 194s, which are shifting the bits and spitting them out over here. We could have a problem with these 194s and how they're shifting these guys. Never know. And then those bits, we have S0 and S1, which are the controls for these 194s. And it's looking like this is just putting out a serial string through pin 15 here on these 194s. It's taking this data coming out of these EEPROMs and serializing it into what looks like 2 bits. You have a bit here and a bit here. This one is going, that's QD and QA. So the most significant bit on this one and the least significant bit on this one. So it's basically taking, you know, the upper bit on one of them, the lower bit on the other, and spitting those out serially here. That one's going into this 157 mux. That's going into this 157 mux. It's creating 2 bits. And we have another bit coming in here. So we got 3 bits coming out of this mux. So we could definitely look at the mux. All these 194s. And these 194s all have a hand in controlling this 157 mux right here. It's spitting out 3 bits. And we got some control logic here. You know, we got the select bit, we got a enable bit, and some gating here, gating logic. You know, controlling the selecting and the enabling of that. Yeah, this mux is, these are just more inputs to the mux. Yeah, and then that comes out as color bits and goes back to the main board, I believe. Or is that the edge connector? That might be the edge connector? I don't know. I'd have to look. Nope, there's the edge connector right here. So this is going back to the main board for whatever reason. Oh, because the video goes off of the main board. So this, we can then follow these onto the main board schematic, these color bits. But one thing at a time. You know, I want to do one bit at a time. So we're on the little board right now. The little board on top. So we're going to start there with all of that circuitry that I just went over. And then if that all checks out and everything's looking good, then we'll follow these color bits onto the main board and see what kind of processing they get handled there. This looks like a black level maybe. BLK3 maybe. What is that? Where does that come from? Oh, that comes from the main board. It looks like that comes from the main board and then gets inverted and becomes the control for this. So yeah, you got 3 bits going to the main board and you got 1 bit coming from the main board. Yeah. Yep, because these 3 bits are the outputs from this mux. Alright, yeah, so that gives us a plan of attack of where to start looking on this. We're going to start at the beginning of this business with, let me find it, where are we? This MapROM, the MapROM addressing. Starting with this 283 right here, and then you have this other 283. This makes an 8-bit counter right here. This makes a big 8-bit block, counting block. And the other sums from this are being instituted into all this control logic for that mux, remember? So this 8-bit counting block right here is crucial. We have to make sure that that's all working good. And the 4th sum bit, yeah, that 4th sum bit from this 283 is another data bit into this guy, this 374. So yeah, we start with these 283s. So we'll fire up the analyzer and we'll analyze these 283s right here. And make sure that they're doing what they're supposed to do. So let me go ahead and throw this video up as part 1, because these things, they take so long to render these videos, you know, to edit these videos and get them rendered. So I'm going to go ahead and stop this one, put this up as part 1, and then part 2 will be all of the analyzing, all of that stuff. And we're going to start right here with these two 283s. Okay, stay tuned. Stay tuned and we will see you then.